Now let us move to next problem type, that is divisibility. And this problem type have been asked in multiple papers and very beautifully questions have been framed on this idea. Now let us see how do we solve questions based on divisibility. So there are these 5 important results that you need to know. The first is if you have 1 plus x raised to the power, I will take an example and explain you, raised to the power 10. Then once you start expanding it, what will happen is first term will become 1, then 10c1x, then 10c2x square, so on and so forth. So you can write this as 1 plus x into an integer that can be written as 1 plus mx. So that is what our first result is saying. Got it? Next result, what we are saying is in this power, if I write an even number, even in case of minus sign, I can use the same statement. By expansion, again, you can realize this result. Next one, what we are writing is if we have an odd power here, then instead of plus 1, you will get minus 1 here. For example, if I write 1 minus x raised to the power 11, then once I start simplifying, what we will observe is what we are getting is nothing but minus 1 plus mx. More appropriate way of writing this would be nothing but instead of this, we could have written this as x minus 1, would have made much more sense. This is much simpler way of writing the same result. So instead of writing it here, let us write this as x minus 1. In the next one, what they are saying is nothing but if we have something like 9 raised to the power 4 minus 5 raised to the power 4, then this is definitely going to be a multiple of 9 minus 5. So this is going to be a multiple of 4. This is a very interesting idea. And the last one says that here we have been doing for negative sign. So any value of n is fine, either even or odd. But if you want to apply this for positive sign, like 9 raised to the power 4 plus 5 raised to the power 4, for this we have no result. But we have 9 raised to the power 5 plus 5 raised to the power 5. Then this is also a multiple of 9 plus 5. Now these 4 results we are going to use in order to solve problems. Now let us start with this first question based on divisibility. Now the trick in solving this question is, when they are saying fractional part, what they essentially mean by this fractional part is, what is the remainder when 4022 is divided by 15? Now that remainder by 15 is nothing but the fractional part. So this is what you need to understand, and this is a fundamentally question based on remainder. Now, once you have understood this first thing, now let us move on to the second idea. Now the second thing is, what we need to do is we need to search for some power of 4 such that it is 1 plus minus the divisor. So here if I take 16, it is equal to 1 plus 15. Why are we doing this? Because in the third step, when you will write 4 raised to the power 2022, we will be able to express this as 4 square raised to the power 1011. That in turn can be written as 1 plus 15 raised to the power 1011. Now in the starting, I have told you very important property that if you have 1 plus x raised to the power n, it can be written as 1 plus mx. We can apply this property and write 4 raised to the power 2022 as nothing but 1 plus 15 into some m integer. Now once we are able to do this, the greatest advantage of doing this is now you can clearly see that from Euler's division lemma that 4 raised to the power 2022 can be expressed as 15 into something plus 1. So 1 becomes our remainder. So in the fourth part, you can see that 1 is the remainder. So the fractional part from here can be written as 1 by 50. So your option C is the correct answer. Now again, similar kind of question was again asked in 2020. So in 2023, the same question got repeated. Again, if you see, what we need to figure out is what is the remainder. So what is the remainder if 3 raised to the power 200 is divided by 8? That is what we want to answer. And if they want the fraction, we'll divide that by 8. The second part will think of a power that is closer to it. So 3 square is 9 and it can be written as 1 plus 8. The third step, 3 raised to the power 200 can be written as nothing but 3 square raised to the power 100. So in the next step, I will be able to write this 9 raised to the power 200, 9 raised to the power 100 as nothing but 1 plus 8 raised to the power 100, which can in turn be written as 1 plus m times 8. So from here, you can clearly see the remainder is 1. So the fractional part becomes 1 by 8. That is nothing but option B. Now this is the better question that was asked in 2023 and it attacks the core of the formula that we derived earlier. So here we'll have to apply a little bit of binomial expansion. So if what I can do is I can write this 2023 as nothing but 289 into 7. So what I can do is I can write this as 289 as 290 minus 1 into 7. So in turn, this can be written as nothing but 290 into 7 minus 7. Now, why is this important? Because 290 can be written as 229 into 2 into 5 into 7 minus 7. You can see that out of this I can get a 35. It is nothing but 35n minus 7. Now, this is very important because we were able to extract a 35 out of it. Now, once you do this in the first step, in the next step, what we want is, if I put a power 2023 over it. So if I write the binomial expansion, what we will observe is, if I write it 2023 C0 35n raised to the power 2023 will come. And we can write all the terms. The second last term is 2021 23 C2021 35n into 7 raised to the power 2022. And the last term is going to be nothing but minus 7 times 2023. Now the interesting thing is, each of these numbers have a 35 into it. So this is the multiple of 35. So now if I simplify it, it can be written as 35 times some n, and what you are getting is 7 raised to the power 2023. That can be written as 7 into 7 raised to the power 2022. So 35m minus 7, and here 7 square can again be written as nothing but 49. So if I write this, this is 35m minus 7 times, this also becomes 49 times 1011, and which can be in turn written as 35m minus, and this can be written as 50 minus 1 raised to the power 1011. Now again I can rewrite this expression as nothing but 35m minus, again if I open it and you can see the power is odd, I will be able to write this 15 times m1, some other constant minus 1. And this was another property that we did. So if I multiply this, you are getting 35m here. This can be written as 35 into 10m1. And then the last term will be nothing but plus 7. So you can see that all of this has a 35 in it. This term is independent of 35 and hence will become the remainder, that is 7. Now this is a more interesting question than the last one because there are two terms involved. Earlier there was only one term involved. If I look into this question, what I can do is the first part can be written as 21 minus 2 raised to the power 200 and 21 plus 2 raised to the power 200. Now why we have chosen 21? Because it is 3 into 7. So factor of 7 will come. And if I write binomial expansion, the factor of 7 will keep on increasing its power and will get 49 as a multiple. So this is the thinking process behind this. So once I do it, let me write my binomial expansion. So since you can see only difference between them is this plus and minus sign, so alternate terms will get cancelled out, and what we get is 200 C naught 21 raised to the power 200, 200 C 2 21 raised to the power 198 into 2 square. It will keep on going like this, and you will see the second last term will be 200 C 198 into 21 whole square into 2 raised to the power 198, and then the last term will be 200 C 200 2 raised to the power 200. Now the interesting part is, if I take terms from here to here, we can see that a 21 square is coming. 21 is nothing but 3 into 7. So 7 square is also there. So these all terms are divisible by 49. Now once you have observed that, so you can see that this is nothing but can be written as 49 into some m, and 2 into 200 C 200 can be written as 1, and this can also be written as 200. So whatever remainder we are going to get, that is going to come from this part. So let us now examine this part. So this was my first step. Let us move on to the second step. Let us see what we can do. So in this next step, I can write this as 2 raised to the power 201. 201 can be written as 2 raised to the power 3 raised to the power, and this if I divide by 3 becomes 3 into 6 and then 21 7. This is what we will get. And 2 raised to the power 3 can be written as 8, which in turn can be written as 7. So this is what we are getting. And if I expand this, what I'm going to get is 67 C0, 67 C1 into 7, 67 C2 into 7 square, so on and so forth. So from this term onwards, you can see that you have a consistent power of 7 square, and this will become a multiple of 49. So whatever remainder we will get from this first part. So let us examine this further. So if I simplify this, it is nothing but 1 plus 67 into 7. And if I simplify this, this comes out to be 1 plus, can be written as 63 plus 4 into 7. And you can see what we are getting is, one part will be 63 into 7. Now this already has 7 square into it. What we have is 4 into 7 plus 1. And you can see that this will become a remainder. So this is nothing but 29. Let us again go back to the question. So if I look into the question, what I have done first is 19 is written as 21 minus 2 because 21 is a multiple of 7. And then 21 plus 2 for 23 raised to the power 200. We have applied the binomial expansion. And we can see that only in the last term, it will not have a component of 7 square. So we have taken them and we are trying to understand what will be the remainder contribution from there. So if I take down that one, you can see that it can be written as 2 raised to the power 3 raised to the power 67. 2 raised to the power 3 can in turn be written as 1 plus 7. We can write its binomial expansion, and you can see that after second power onwards, 49's multiple will come. So remainder will come from the first two terms, that is 1 plus 67 into 7. 67 can in turn be broken down into 63 plus 4. Why 63? Because again it is a multiple of 7. So 7 square will come if 63 and 7 got multiplied. And then 4 into 7 plus 1 will become remainder, that is nothing but 29. Now if I move on to this next question, it is very interesting because again we get to use the properties. So what they're saying is, first you find the remainder after dividing by 3, that is nothing but alpha. So let us see for 3 first. So for 3, 22 can be written as 21 plus 1 raised to the power 2022. And this second part is nothing but a multiple of 3. So we can write this as 3m raised to the power 22. So this is already a multiple of 3. So from here the remainder is 0. And this if I expand, I will be able to write this as 1 plus 21 times m dash. So you can see that from here also this number is a multiple of 3. The remainder comes out to be 1. So from the first term the remainder is coming out to be 1, the second term 0. So the value of alpha after adding both of them is nothing but 1. This is the first part. Now the second part of the question says that in order to find the value of beta, we'll have to divide by 7. So again, for finding the remainder from 7, what we can do is the first part, it is again can be written as 1 plus 21 raised to the power 2022. And the next one we can write this will become nothing but if I divide by 7 minus 1. So this is how we can write this up. So if I simplify this, now we can see that this can be in turn written as nothing but 21 times m plus 1. And this can also be written as something like 7m into some m dash plus 1. Why plus 1? Because here the power is even. So this minus sign will have no impact. You can see that from this first part also, the remainder is coming out to be 1. From the second part also the remainder is coming out to be 1. So the total value of the remainder comes out to be 2. So value of beta becomes 2. If we want alpha square plus beta square, it becomes 1 square plus 2 square comes out to be 5. And let us see how we can do it. So again, this question is specifically based on this property a raised to the power n minus b raised to the power n will be a multiple of a minus b into n. So let us see how to apply this property in this question. So if I first take first and third term and second and fourth term, and if I write 25 raised to the power 190 minus 8 raised to the power 190 and minus sign 19 raised to the power 190 minus 2 raised to the power 190. From the first two terms, what I can write is nothing but this is going to be a multiple of 25 minus 8 times m1, and the next would be a multiple of 19 minus 2 times m2. So if I write it in this manner, what you are getting from the first one is 17 times m1, and second also becomes 17 times m2. 17 we can take common, it becomes m1 minus m2. So what you can see is this expression that is given to us is a multiple of 17. 17 is definitely there. Second, what we can do is I can combine first term and second term and third term and fourth term. If I do it in this manner, so it becomes 25 raised to the power 190 minus 19 raised to the power 190, and then minus sign I can take common, 8 raised to the power 190 minus 2 raised to the power 190. So if I write it in this manner, again the first will be a multiple of 25 minus 19 into m3, and the next I can write at minus 2 into m4. So again you can see that here from the first one it becomes 6 times m3, second also becomes 6 times m4. So we can say that this is a multiple of 6. What you are getting from here is very simple idea that the given expression is multiple of two terms. One is 17 and another one is 6. 6 can be written as 2 into 3. So if you have this much, now if I look into the option, they are talking about divisibility by 14 and 34. See, 34 is possible if I take 17 into 2. So 34 is definitely there is no problem. But 7 is not possible because any of our factors that are coming will not make 7. So option D becomes correct, that multiple of 34 but not 14. If I look into this next question, what it talks about is two statements are given. In the first statement, again the same properties, x raised to the power n minus y raised to the power n is a multiple of x minus y into m. We can apply the same property. So here you can see that this is 2023 minus 1999. This will be a multiple of this part. And if I write that, you can see that it will become a multiple of 24. So if it is a multiple of 24, obviously it will be divisible by 8. So this first statement is correct. So this one is true. There is no problem. If I move to the next part, what is given to me is 13 raised to the power n plus 1 minus 11n minus 13. What I can do is the first thing I can write this part as nothing but 1 plus 12 raised to the power n plus 1 minus 11n minus 13 and write its binomial expansion. So n plus 1 c0 plus 12 times n plus 1 c1 and then n plus 1 c2 12 square, so on and so forth. So all this would be a multiple of 12 square, and then what is written is 11n minus 13. If you look into these first two terms, this is exactly equal to this part, so they will cancel each other out, and what you are getting is 12 square I can take common from the remaining terms, so n plus 1 c2 plus n plus 1 c3 into 12, so on and so forth. Now this is an NCERT level question, so this becomes 144 times m. So you can see that it is a multiple of 144. So this statement is also true. Hence both statement S1 and S2 are correct. Option D becomes correct. Now if I look into another question that was asked in 23, what they are writing is the 50th root of x is 12. So what they are writing is x raised to the power 1 by 50 is equal to 12. That would imply x is nothing but 12 raised to the power 50. And the 50th root of y is nothing but 18. So that would imply y is nothing but 18 raised to the power 50. What they're asking next is if I write x plus y. So it would be nothing but 12 raised to the power 50 plus 18 raised to the power 50. So what will be the remainder if this is divided by 25? That is what the question is. Now, what you can do is in this question, we need to apply binomial expansion by, because of our property x raised to the power n, y raised to the power n. This is only valid when n is odd. That would mean here you need to have an odd number like 2n plus 1. And here also an odd number like 2n plus 1. Only then you can write that this is a multiple of x plus y into n. Otherwise you cannot apply this property. So this property is not applicable in this case since the powers are even in nature. We cannot apply it, hence answer cannot be 0. So what we need to do here is we need to write binomial expansion, go one step before. So what we can write this as is 15 minus 3 raised to the power 50. And the next one I can write is 15 plus 3 raised to the power 50. And simplify. And now this similar kind of question we did earlier in this discussion. You can follow this discussion and come up with an answer. The answer of this question comes out to be 23. Now let us start with this next question. In this next question, what they are saying is if I sum this up, The first part is based on sum of a GP. So first what I need to do is apply the sum of GP. So it becomes A into R, that is 3 raised to the power 2022 minus 1 by 3 minus 1, because there are 2022 terms in this expansion. If I find this and then I divide this by 50, what is going to be my answer? What is going to be my remainder? That is what they're asking. So let us simplify this. So this becomes 1 by 2 times 3 raised to the power 2022 minus 1. Now since I want to talk in terms of some half of 100, so it makes sense that I write this as 3 square raised to the power 1011 minus 1. And I can further write this down into 9 raised to the power 110 minus 1. And if I do that, what I can write this further as nothing but 10 minus 1 raised to the power 1011 minus 1. What is the benefit of doing this? Now that we are going to see in the consecutive steps. So if I do this, 1 by 2 is fine. Whatever is inside can be expanded and written as 1011 C0. So this will become 10 raised to the power 1011. Next, there will be a minus sign 1011 C1, 10 raised to the power 1010, and this will go on. But the last two terms are important. So last two terms will be 1011 C1010 into 10, and last one would be 1011 C1011. And then obviously there is this minus 1 from above. So if I do this, see, this last two terms are very important. Why these are two very important? Because the rest of the terms, if you look into this, they will always have a factor of 10 square. So if I divide by 2, it will become 50. So what I can write in the next step is this is nothing. And then if I simplify this, this becomes 1011 into 10 minus 2. Now if I bring this 1 by 2 inside, what is going to happen is in the first part it becomes 50m. In the second part it becomes 5055. And this becomes 1. So if I simplify this, so what I am getting is nothing but 50m. So this part is fine, taken care of. The rest of the part I can write is 5054. And now clearly you can see that if this part, if I divide by 50, the remainder will come out to be 4. Hence 4 becomes 1. Now this extremely simple 2024 question asks us the remainder of this when divided by 9. So what we always seek is some factor of 9 plus 1 plus minus 1 should come here. So we can easily think upon 7 into 9, that is 63. So this can be written as 63 plus 1 raised to the power 32 raised to the power 32. And this can be written as nothing but 9 into 7 plus 1. Now we know that from shortcut that if you have nothing but x plus 1 raised to the power n, this will ultimately be able to express as nothing but mx plus 1 type after binomial expansion. So remainder will become 1. So in this case also it can be written as 9 into some multiple plus 1. Hence the remainder will become 1. 60 days to JEE means, let me tell you something that nobody else will. The brutal truth. Right now you have doubts from class 11th you never cleared. Topics you are avoiding, formulas that you kind of remember. And you are thinking 60 days is enough to fix everything. Here's the reality. It's not if you study randomly. At PracBee, we have produced 10 times better result than national average and helped more than 500 plus students jump 80 plus marks in last 60 days. How? They stopped trying to cover everything and focused only on high weightage topics. They cleared every doubt. They had a strategy into place. And that's what Last Lab Booster program does. Senior ITN faculty sit with you and develop a 60-day roadmap. Expert teachers guide you 1:1 daily. Every doubt is cleared in 24 hours. Not random prep, but strategic warfare. Ashesh, Ditya, Sauri, Sarthak, we are all able to improve from 150 to 250 in a matter of 60 days. Real students, real result, 60 days. But time is less and our slots are even more limited. Click the link below, book a free strategy session or regret it on 1st Feb. 60 days, your move.